is one of my least favorite ones that I use throughout the year, but some students really relate to it, so I don't trash it. I still use it.
It's not as funny, but it's very good.
I like them to be a little bit math related.
Yeah.
I was lucky. Actually, the one time I got ticketed, I didn't wear my kids going to my dad's car. Isn't this different? Right now, you said the you'll say about it. Did you read it? I did my best.
I And so it like puts it in a totally different place. So no, I just be careful. Don't worry.
I didn't know that they even I just know that she had their session.
Frankie Cooper.
Same day.
No, I had it 7th grade. So I had to have this for that.
Oliver Matt.
I think I just make a deal. Say, hey, if you guys stay an hour and 30 minutes.
Thompson.
Pretty good idea.
Yeah. For my graph. I know, I saw you walking up. I was like, I know. She was like, oh,
Make sure you know how to. This one is calculated.
All right, guys, to get started this morning, I need to give you one more chance to turn in your bookwork number 22. So I asked you guys to do that yesterday during class. You could have done it for homework in Google Classroom, but if you didn't do it during class, you forgot that it was homework, your internet didn't work, whatever the reason was, this is your last chance to still get full credit and it not be late. So you need to make sure that you've turned that in, and if not, put your name on it and please bring it to my basket up here. And that needs to be done now, not later in class, if you want full credit. After that, we got 2 new handouts this morning. So I almost never give you guys 2 circuits in one day, but that's just kind of how things fell here. So the one I'd like you to look at first, number 26, is actually not really a calculus thing. It's about using your calculator. So every one of those questions, they want you to try to solve using your calculator, even if you can do them by hand. It's practicing calculator skills. Now, most years I do this later on in the year, but there's a lot of these things that are just kind of expected that you know. So I thought maybe it would be good if you practice some of them before they start popping up randomly. So I'd like you to do that one first. So just using your calculator, hopefully learning a few new calculator tricks, finishing that up, and then I'd like you to practice 27, which is just one more practice time on product rule, quotient rule. And by next week, you guys need to feel very, very comfortable with power rule, product rule, and quotient rule, because we will need to move on to chain rule. And you don't need to know what chain rule is or how it works today, but I can give you a heads up that chain rule is just an additional step. So you're still going to do power rule, and then you might have to do chain rule after. You might do product rule, and then you might have to do chain rule after. quotient rule problem, and then you might have to do chain rule after. So if you're struggling with power rule, product rule, or quotient rule, it's only going to compound when we throw on chain rule on top of that. So that's just a heads up to make sure that you're putting your best effort into number 27. Now, depending on how good you are with your calculator and how comfortable you are with product rule, quotient rule, you may not have any homework, but I would like you to finish those up. So the more you get done in class, the less you have for homework. And there is one assignment I'm asking for in Google Classroom before the start of next class. So I can tell you what that is, but you got to log into Google Classroom anyway, so you can see what it is when you get there. But that's on the agenda, so as you finish those up or you look under the homework this weekend, you can get your reminder there. Okay. Any questions about the plan for today? Okay, and as usual, if I see the same type of question pretty often, I will ask that you guys pause for a minute and explain on the board so everyone can benefit. But short of that, you're welcome to work quietly with your neighbors. Well, you could grab all of this as one equation and then grab this as one equation. And you can calculate the intersections. Or, if you'd rather, you can subtract this over, graph that line, and then your answers are explained zero, so that would be a intersection. So whatever you do. trying to put in a couple of the homework grades real quick, and then I'll be coming around if you have questions. You should do the calculator one first.
My calculators.
You can always borrow one over here. Just put it back if you need to.
Well, you know how square root comes to the 1/2 power? Either is for the 1/3 power. You can do the first one.
Yeah, it is.
Well, you can. I think this is better because it reminds you what a square root or cube root means. But I think if you hit 3, you want to give it and it's going to math. See that number 5 that says star root? I think if you hit that, yeah, it knows it's a cube root. But then you got to memorize all that too. So.
Thank you.
I'm still on that one I asked you about, so like I put it
Okay.
in my graphs. And then I went on
Okay, wait a minute, hold on, let me just do white again. Yeah, you don't have this typed in, right? Because your calculator's gonna do word operations, so it's gonna do 2 divided by x, and then come along and add 2. So you need parentheses around x plus 2. Or, let me give you one more tip. Before you do that. Go ahead and clear that out. If you do alpha y equals, option 1 is telling us you want a numerator over denominator. So hit enter there. And then you can type it in a little bit closer to what it actually looks like, and you don't have to be as careful with parentheses. You can write, you can subtract that over, graph all of it, minus 10, and then it can be x ups, because that's already 0. Or you could graph this as a line, graph this as a line, and then intersection. Same thing. Whatever comes in here.
Now, as always, if you get to a question that you didn't know how to do in your calculator, or there were some buttons to get to some menu that you didn't know about or you had forgotten about, please put a star by that question or circle that question, mark it in some way so that if you look back at this paper in 2 or 3 weeks, you can remember which ones were issues and you don't have to start over from scratch. Technically, you didn't. Yeah. The only thing is, like, you can't always rewrite it, so you still need to know project. Personally, I'm fine with whatever you think's easier. I think multiplying and power rule a few times is easier. That's what I would do, but.
Zero is when y equals 0, and when y equals 0. So is 1 is 10 equals 7. Okay, and then move your cursor to the left before you hit enter on left bound. Your cursor to the left of that cursor. Enter. Now right bound means to move it to the right. Because you could have more than one, so you have to tell your calculator. You're telling it, look just between these two, I'll use a 5 and 0. Yes, and then 3 decimal places. Make sure you guys round to 3 decimal places. That's what we always do in this class. Even if it doesn't say round to 3 decimal places, round to 3 decimal places.
I thought 4.2 centimeters.
And again, I know on this calculator one, you can work some of these by hand, but that's not what I'm asking you to practice. It's great if you can, but I really just want to see if you know how to do it with the calculator. As I've mentioned a few times, your AP test will give you questions that are unsolvable by hand, and they expect you to just use your calculator. But also sometimes they allow a calculator. And so even if you could do it by hand, it's going to be a lot quicker to use a calculator, and that's what they're expecting you to do. Insist on doing it by hand, you may not have time to get to other questions on a real test. You can't type it in like that because order of operations is doing this division and then doing this addition. So it thinks you have 2 over x plus 2, not 2 over x plus 2. More parentheses or, figure that out. If you do alpha y equals this first option, that's like numerator over denominator. Yeah, so hit enter there. And then it looks a little bit more like that. So either one's fine, but with parentheses, the only way you're always going to know if it works is if you put parentheses around your numerator and then parentheses around your denominator.
I would have
Every
to
single
put
time.
parentheses around this though.
No, because it's when we do a big fraction, it's implied. You do all the numerator first and all the denominator first.
Okay.
Fine, next. So there's implied parentheses. You don't need to. You could graph this line to your calculator, and then graph this line to your calculator, and the solution would be with intersections. Or you could even subtract this over and graph all of it, and then your solution would be whatever this also works like intersections.
Like that, and then that, then I do something, and then you just find this, read it. So you need to plug 3.2 into this.
It's easier to see.
I think I know what you're talking about, but that's a lot of work. I mean, they just want you to plug this in here, so in your calculator, you can in at 3.2 squared, you're gonna get a number.
Yeah.
And then that number goes in for x, so then you plug that number in here, you can get a new number, and that's your answer to the question.
Wait, what were you also?
This is the one.
Yeah, you might say.
This first one that you typed in, this isn't tangent x squared, it's tangent of x squared. So the way you wrote this, you squared this whole thing, and this time you actually only want to square the 3 sides. So squeeze that square in for instance. That's what I want to see if you can do. So I would probably graph this as an equation and this as an equation, and then the solutions would be the intersections. Okay, but the absolute value, do you know where to find that in your calculator?
Yeah, so it says there are two solutions to this and so
Okay, yeah, that's one of the places. I honestly don't ever really remember that, so I go to second 0 for catalog, because everything's under catalog. And then it's alphabetical, so absolute value. So just graph all that, and then your solution should be the intersection.
Again, obviously, please speak up and let me know what parts you don't know how to do, because if everyone could do all of these already, then I wouldn't be spending our class time on it. Everybody should be picking up a few things from these problems.
Well, you can graph all of this as a line, and then graph all that as a line, and then our solutions would be the intersection. Mhm. So where those are equal is when the lines are in the same place at the same time. Or if you'd rather, you could really subtract this over and have one big line, and then your solutions would be when it equals 0. So that would be x intersection. Either way.
For this one, is it faster to multiply it by 3 divided by 4, 5? Because I did that and I didn't get an answer that was on the page.
Well, can't you just type it all in at once? 4/3 times 5 times.
Is what I'm looking for.
What are you looking for?
So just do X there.
No, because your calculator probably doesn't have that sorted. Just do like in parentheses. Yeah. Times 5. And then parentheses times r cubed, but we're gonna say. Oh, my bad. I thought you were just getting volume, and you had radius. Okay. So if volume is 4.5, you should do 4.5 divided by,
No, you're right.
and then move the rest of that stuff over.
And then multiply by 3. And then divide by 4, 5.
Okay, that's correct. So what do we got? When you did this, I think it may have multiplied by pi. Because of order of operations. Okay, now make sure you put that 4 pi in parentheses though. Because if you don't, it's going to divide by 4 and then multiply by pi. You really mean to divide the whole thing. I'm not sure about your calculator stuff, so I don't know what you did there at the end. But no, I know, but you had an extra line and then you erased it somehow. I don't know what you did there, but I think it looks fine for what you just did. But you can graph this as a line, and then graph this as a line, and then the solutions would be the intersection.
So I'm gonna try and type it on this one.
Where they're at the same place at the same time to be your solutions. Or if you'd rather, subtract this thing over, grab all of this as one line, and then the solutions are where it equals 0, so that would be x-intercepts. Whatever sounds easier.
On this one, because
You can't just square it in some of them here. Because it goes like inside the parentheses, so you can find the answer for each seven square root.
No, you're gonna do sine of this stuff in parentheses, and then put the square outside.
But one thing that I
Or you can do sine of whatever times sine of whatever, and that's the same as sine.
So
this equation,
you're gonna
drop
drop
10,
but like now
just find the intersection.
something.
this as a line, and then graph this as a line, and your solution would be where they intersect. Or some people prefer to subtract this over, graph all of it, and then where it equals 0 would be the x-intercept. So whatever sounds easier. That's a really nice handwriting. Oh, I thought this was. I know. Right here, it looks like you're splitting apart your fractions. Right? I'm good with this one. The 7 over the square root of x, you can move this up and x with a negative. So over here, 3x over the square root of x. To divide things with the same base, you have to subtract the exponent. Oh, okay. I can't, that looks like 1.
Yeah, that's what
Okay. Oh, you just put it in the circle.
I just forgot to take it here.
I got you.
So I found these instructions on the website, but I'm not sure.
For this one, you don't need to type in the whole piecewise function. I just want you to think about, do you want to know h at point 9? Which one of these two should you use? And then plug it into that part. this side and then graph this side and see where they intersect. But you have to know where absolute value is in your calculator. Do you know where to find that?
Yeah.
That's already late, so.
Mr. Johnson, can you remind me again how I put the, like, numerator over denominator in the white board?
I will, but he has a camera too.
Still.
Okay.
Graph
Yeah.
that.
Okay. And here's, when you go to this table, it's jumping these x values by 1, so that's not nearly accurate enough. So go to your graph. We wanted to tell our calculator to tell us what that x-intercept is, like as accurate as we can. So if you do second trace, and then pick out a 0, which you want to know where it equals 0. Have you done this before? Okay. So it's going to ask for left bound, because there's more than one. So you need to make sure your cursor is to the left of the one you're trying to find before you hit enter. That's good. That's funny. It's going to ask right bound, so move it to the right before you hit enter. Okay. And then you see how it has these like 2 little lines? So you're basically about to tell it, find me the 0 between. So hit enter to skip guess. And then it will bounce back and forth and it will tell you within like 7 or 8 or 9 decimals. We need a second choice. So there's one answer, you need to do the same thing over there too. I'll give you those. And that's, really you should be using that second trace menu for intersections, zeros. Just looking at the table is not accurate enough because the x values are jumping too big. Okay. Did you do alpha y equals?
Yes, I got it.
Oh.
When you're finding an intercept and you go around, is the fastest way to do it to just hit zeros? Or like when you're adding y zeros, or you have to like do y equals zeros and find the intercept about zero?
Well, how do you type in y equals 0 in your calculator? Okay, you could do that, and then you could ask it to calculate an intersection, or you could just not graph the 0, y equals 0, and ask it to graph zeros. It's the same thing.
Okay.
So, whatever sounds better.
Text yesterday. No. I know. I agree.
So it looks like you're getting the common denominator. The common denominator would
I
be
put it
2,
on, but
whatever you're at. And that's what you have here. You're talking about cross multiply. Cross multiply
so
an
I
equation.
made it in table 7.
So what it is?
And then you do 2 now.
This line, I know that you're doing
And then you'll do x minus 2, or x minus 2. You'll do minus 2. And then you'll do 2. And then you do table 7.
There's a minute because he was.
That's what I did. I did it and we left.
let me work it, skip that one for a second, let me work it, just looking at yours, I don't see anything, so, let me finish this question now.
So I'm on this one right here, and I put it in my calculation, and I think for the maximum, so I did second trace, and 4, and then left bound, so I go to the left exit.
How can you see the maximum in there?
Yes, okay, yes.
Are you sure you're to the left of it? I think she's too zoomed out. Hit zoom 6 to change it back to standard zoom. Standard is -10 to 10, -10 to 10. Now I can actually see the max. So now you can figure out where your cursor is. I think you were so zoomed out it you could actually see the max. Where? Natural? Okay, how much about it? It's in these menus somewhere. I know it's also under alpha window. The first option, but I honestly don't usually remember that, so what I do is go to section 0. The catalog has everything, so if you're willing to scroll long enough, you can find it. Absolutely, at the very top though, ABS. But anytime you know your calculator has something and you can't find it, the catalog is a good place to do it. Because
What
it
would
will
9
do
through 11? So I could find your school. So you need to type your box. Your 11's here. Not 9.
No, I didn't.
Just skip to it.
It sounds good.
I think I missed the sign.
Inverse because you're typing in inverse. You need to do 1 over the cosine of that. Inverse is where you switch the inputs, like you're plugging in a ratio and wanting to reciprocal just means you want the fraction. Like that. You're in degree mode. All three functions.
I guess that's.
Wait,
Everything
because
you can
that's
do.
the.
Which box is like? If you don't feel like that's comfortable, like if you're not sure if that's right, like on a test or something, you could always do sin 2x times sin 2x, and that's means sin 2x squared. And then that gives you
When I looked at this maximum, the same was 2.6.
What's the question?
One of them is on the maximum value.
Wait, what did you remember that? We got the same thing as in last week.
Are you telling me the maximum value or where the maximum value occurs?
Oh, so then you plug that in to the box. No.
There's no need to. They've already done it for you. Y represents that max value. The X represents when it's occurring. The Y is the value.
You plug in the numbers that reach like the standard work, so like 0.9 would be from the top, and another one would be the same, and you figure out which one is the larger. So then there's the size function, so on this side, you see how x has to be less than 1 for it to work, so this is the only piece of data that will work on that, and then the same for this side. So you see which one you plug in, so the values after you plug into this and this. There's a major value on that one, is that one, or is that the main
order you're supposed to like do.
Rewrite, or something there. And then I started looking up some of the answers that we were making them. So it looks like they got a common denominator by multiplying this by x over x. So now there's 3x minus 7. And the common denominator is 2. And instead of calling this x to the 3 halves, they left it as x times the square root of x. Which is kind of a weird way to do that, but that's what it is right there. I don't know. One thing that you can do, if you ever want to know which one is sometimes.
I was gonna say if you can factor out those three, try to make it.
Yeah, it's probably something like that. But sometimes what I'll do is I'll just like throw some really weird number in for x, and then if I type in theirs, get a decimal, and then type in mine, if it's the same decimal, then I know it's equivalent. If you do something like 1 or 0, then you might trick yourself into thinking they're equal. You turn it in hard copy. Second trait. Maximum. Left bound, so move your cursor a little bit to the left of it. And right down, move your cursor a little bit to the right. It's gotta be to the right. You see these little lines? So you're about to tell your calculator, tell me the biggest value between those x's. Because there could be more than one max, so you have to narrow it down. Hit enter to skip guess. And then it will give you, this is the max value, and this is when the max value occurs. A lot of people think this is the max value is the y.
Is this one right here, the negative 2? This one is it's the y value. The y value is going to be the real one.
Borrow one.
We have to mention oh, my bad. Yeah. Thank you. It's just like you have to set your table up the right way. And then you just write whatever x value you want. And then you invert that's fine. Yeah, it helps you kind of see everything in the graph. Like this one.
I don't think the calculator can be able to graph this too far. If it can, then more than that, you'll have to divide it. You don't have to practice it at all. It is only that base at 0.9. So if it's 0.9, which one would you match that? Okay. So they just want you to put 0.9 in here on the home screen, you have a number. And then 1.1 is when x is greater than 1. So plug in 1.1 here on the home screen. You don't have to try to graph it at all. Trying to graph is way harder to do. Your second trace max. You're spamming the enter button that's right there. Okay, left bound is asking you to move the cursor somewhere to the left of the max. Max is somewhere over here, so you can hit enter now if you want. But then the next one wants right bound, so you need to move the cursor somewhere to the right of the max. Because the function could have multiple maxes. So you've got You see these lines? You're about to tell your calculator, tell me the biggest value between those two. Now hit enter to skip guess. And then jump through that. The X value will tell you when it occurs, Y value is what the value is. Why? It looks like it's going down further.
Below the cross section. That's what the question is.
What's this other function? What's the red function? Okay, so this is what you're trying to solve. Well, the solution is the x value. This is a smaller x value because it's further to the left. You know what I'm saying? You're looking at y values, but the solution is an x value, so you should be looking at the furthest left x value. But you still need to find both of them. It's just that you use one of them to know how to move forward. You still need to write both down. You always need to show your work. Closed interval just means this is telling you that you only care about 2 to 4. So when you graph this, I think it's going to be so crazy. Okay, so now go back to your graph. We don't want to do this one. We only care about the x. Make the smallest x value 2 and the biggest x value 4 and regraph.
Oh, I'll do that now. Oh, okay.
Now you're like zoomed in to what you care about in this question. And now you can push it.
I thought it was the, oh, that's not, yeah, I thought it was the, no.
And when you're done, you probably need to do the zoom 6 so that you're not stuck in that same thing. This graph's different. Oh, that's why you're graphing. Okay. So 0, left bound, right bound.
Yep.
Answer within 3 decimal places. So when it says interval, it's just you're saying these are equal an infinite number of times. We only want the answer between 2 and 4. The closed part means that they included 2 and included 4. Whereas sometimes open would mean the numbers between 2 and 4 but don't include 4. That would not have changed how you work that question.
So, that's so right, actually.
So I think I saw that they're gonna release a new version of that.
Of the phone?
Oh yeah, like when you get a new phone someday, are you gonna get another phone like that or not?
Did you get,
Yeah, I really like it. Cool. It's nice and so think that's what I'm gonna have to get on my next phone.
Yeah. Like they made the screen like this big, so now you can like do calendars and stuff. You have to open things.
I used to upgrade my phone once a year,
Yeah.
and now
It's hard to keep
I'm
up.
like one of those people with the cracked screen.
You don't have to worry about that on this one.
Yeah.
All the plastic.
You just plug in.
It just seems silly to spend several $100s to get like
Yeah.
95% the same thing.
Are these McDonald's coffee? Are those still $1 on the app?
No, I don't think so. I think they're like 2 now.
I think I drank like 400 of those when they were $1. Interval just means that you only hear about the answer being 2 and 4. Close just means that you should include 2 and include 4. Open would mean the numbers between 2 and 4 but don't include. So when you graph that, what's gonna happen, your graph's gonna look crazy, and you're gonna intersect an infinite number of times. But if you change your window to only look between 2 and 4 on the x values, you can see that there's one intersection.
So if I choose those, I got negative 0.1, positive 2.
You guys got any calculator questions I can help with?
Oh. 0.1.
Any calculator stuff coming up? I think I'm good.
Am I doing something wrong?
Yeah, right here, you're using inverse cosine.
It's just, that's what I tried to. That's what I did at first. For it to probably see.
Okay, yeah, secant's 1 over cosine, which is not the same thing as inverse sines. So 1. Okay, so secant is 1 over cosine. So I'm good with this cosine being down here, but it looks like the x should still be up in your numerator and you move it down to your denominator. So I think if you redo that and put the 0.9 in the numerator, that first part will be fine.
Okay, thank you.
Well, that's one of them. Well, here's 0, and there's another intersection. So you need to find that intersection. So do the same things that you did. Leave the cursor near that intersection and you hit enter. I don't mind if you're, I don't know if you're trying to use the table or not, but you need to be careful too. I'm not usually after the previous one. Yeah, I think it's just the last person who used that, got the table up there, but you should still be able to do this over to the left. What are you trying to find out? Do you care about the X interception?
Me too.
Okay, so I see the 0 there. There's the bonus. Let me look at how you type this. I don't think it should be that far. Yeah, it's the way you type this here. You calculate the order of operations very quickly. Let's do this division first and then add. So making sure you want 2 over x plus 2, not 2 over x. You know, add more parentheses. The number of 14.
I got that 2x. There's anything else. This one might be the 4.2.
Shorten that.
That's how it has to be.
Wait, cameras for this. Go down, look at the utilities. And then try to move the cursor where it thinks you have to decide. Do I FOIL these? I bet. Right, but I bet you typed in -2, not -2. Now try to take graph. Yeah. So in mathematics, a negative and a minus are very similar, but for your calculator, it's minus. Yeah, because it thinks you're saying nothing -2, so it doesn't know what to do.
Add prime of x plus or times your
Again, I always make it smart, but I'll say it at the start of class. And I put it up here.
Front
You
page
check
is
the side.
2x plus 1.
Well, it's due, start next class, so if you don't turn it in now, you gotta do it for homework. And then you're gonna rest it. So.
If I turn this in now, then do I have to upload a picture of this to Google Classroom? Or
No,
just-
you can do the hard copy.
I don't know how this function works. So I don't know why it's in here. Finish problem. What I'm gonna do is just graph it, visualize where it looks like the head point, and then do that like trace, and do math, do left down, right down.
What is it? What's the derivative
But on
of
that one,
this?
you have to be careful, I think it says max value. You take the derivative of y. When it has
Okay,
effect, how
so
you
what's the
use
derivative of 2x? Thank you.
2.
And what's the derivative of
Okay.
So the derivative of this is minus 2x, so just do x plus 3x plus 7, because it should be x.
more answers?
There's 6 years.
What are your answers? Just write that one down on your list.
Got two,
And then the box.
6, 4, 6.
Okay, and there's another one over here you need to find.
Yeah. It is.
I think we go to, yeah, we did ask them to do intersections, you've only got one graph. Oh, okay, I got you. Then, do intersections or zeros. So I think you're skipping through these steps too fast. That's why it doesn't know which one you want, it keeps giving you the right one. So when it says first curve, you need to put the cursor closer to that one before you hit enter. Okay, yeah, now it's gonna know which one you want. So there's your other answer. And then it says it wants the sum of those, so you need to add those all together. Equations on there?
Yeah.
For what question?
Like the ones in plastic that you send me to, like the ones that graphically,
I meant to talk about this with y'all, but they have limitations too though. What if, well, some of these questions have two answers.
I just couldn't hope you did.
Well, how do you know there's only two answers? What if there's five? How do you know one split? That's true, but usually you don't, they're only giving you that hint so that you know how to move forward. I mean, this skill can do. So yes, I like this and use this too, but again, if you don't know how many answers there are, you kind of don't know when to keep going. Whereas the graph, you get kind of a visual, I guess it could intersect somewhere off the graph, like say for something. Mhm. Yep. Yep. Let's do that.
And they're all very similar numbers.
X are 2 cosine of x minus x
Except for the
times
negative.
f.
Okay, what's the three answers?
The negative.
That's when the maximum occurs, but not the maximum value. The maximum value at that time is that, so you want to wipe out.
Okay, there is one thing about the calculator I want y'all to be aware of. I don't know that it's better or worse, but I think most of you guys don't know this exists, and it is good for you to know it exists and to know the limitations. So even if you're finished with the calculator part, if you could bear with me here a second and follow along. I still get paper real fast. Okay. So let's find one of these that you're supposed to solve. I think box number 8. Do y'all see the one that says f of x equals e to the x minus 4 plus 2.5x minus 11.7? Y'all see that question?
Yep.
Okay. I suspect most of you guys graphed that and did calculate 0, and that's fine. But I need you to be aware of this other thing on calculators. If you go to math and then go all the way down, you will have something that's called equation solver or numeric solver. Now, depending on your calculator, this part could look a little bit different. But basically what it lets you do is it lets you type in one side of your equation and for E1 the other side of your equation in for E2. But here's the thing, just knowing this exists is not enough. You're not going to know how to use this if you don't practice it occasionally. Again, I still think the graph is better, but if you type in one side of your equation for E1, one side of your equation for E2, you go down to OK. This is not your answer. This is actually the answer the last time I asked it to do this. So whatever number I type in here is kind of like my guess. Like, I think the answer is near 50. So my calculator is just going to start there. If I give it a wildly wrong guess, it just takes it longer, but it's still going to be a second or two. So notice, you see how the alpha button is in green? Well, what is in green above the enter button? So if you hit alpha enter, what it will do is it will find the answer closest to my guess that solves that. So you see how you also got that as an answer? Yeah.
Instead of alpha solve, you can press the graph button.
Graph?
Yes.
Oh, okay. That's fine too. So to me, that's probably quicker than making the graph and then finding the intersections. So in some ways, this is nice. But the problem is, like, what if my equation was, I'm just going to make something real easy. X minus 4, x plus 4. You see how this has two answers, 4 and negative 4? Well, equation solver, if you do alpha enter here, it's going to give you one answer closest to the one that you had, and it's not smart enough to know, hey, there's other answers and you may want them, you may not want them. It just gives you the closest one. So if you want the other one, you kind of have to have a clue that there's another one, pick a different guess, and do alpha enter, and it can find that one too. So sometimes the equation solver is nicer than solving by graphing, but if you don't know how many solutions you're supposed to have, the graph is a little bit nicer because you can usually just visualize and see real quick which ones there are. So again, I think that's a pretty useful tool. I guess it's not really necessary if you're proficient enough with your calculator, but if you practice it sometimes, you may also think it's a better solution at times. So math, very bottom, equation numeric solver, you have to know how to type it in, you have to know how to change this to get the solution. And again, if you wait till the test to try to figure those things out and then you try to do it on the test, I can't help you with that on the test. But if you practice it once in a while, then it's at least a tool that you could use if you decided to want to use it.
So I wrote this out, and I know this is arrays. I'm just confused as to why this is a subtraction sign. Because the regular equation is just like this. Minus everything. But I have to just oh, sure. No.
Yep.
It's like exactly the same as the other one, it's just the expansion one is different.
I said it was this.
Well, my brain must be doing the same.
Oh, yeah.
Oh.
No, it's all, wait, it's, so it's just.
You're right. Product rules to add.
Product is one of my. I've done it a few times and I keep on getting missing it.
So that numerator looks familiar to me. Okay.
But I still don't see this.
Well, what's 1 over cosine the same thing as? Different trig function. Okay, so then 1 over. Right. Now that you've done all of that, isn't that one I asked you to memorize? Derivative of tangent and squared. Well, that's what you have to do if you don't memorize them.
Yeah.
So. Without a hint, too. Yeah.
You can find those all in the list of all the
These calculators only have sine, cosine, and tangent, and inverse sine, inverse cosine. If you need secant, cosecant, or cotangent, you need to know how those are reciprocals to those. Yeah. So anybody that's using those should know that relationship, so they don't program it that way. Now, if you ever get like a TI Inspire, which has a whole different menu system and takes time to learn, but it has a trig button, and then it does have those programmed in. But
Mr. Johnson, how do you do also?
you have to find it in the menu systems. The two places, one place I forgot until this morning. If you do alpha window, you know how we do derivative with this sometimes?
Yeah.
Absolute value is number 1. I don't usually remember that though, so I normally do second 0 to go to the catalog. But the catalog has everything, and absolute value is great because it's the first one alphabetically. Oh, this is a solver. Yeah. The other thing is though, see how you have these like right here? I think that's because you have a newer TI-84, but I think if you have like an 84 plus, it's not the color edition stuff, I think you have to do alpha in here, so. It kind of depends on how new your stuff is. Okay, well, we're solving for x, so you can graph this, and look for an intersection. Here, wait, we'll clear that out real quick. Let me show you the fraction trick. If you do alpha y equals option 1, lets you type it in as a fraction, and then you don't have to do as many prints, you can manipulate it. You don't have to do that, but it's a little thinner, it's a little easier to not type in something like that. So we'll get a graph, and you're going to create a graph here. And those two things are going to intersect infinite number of times, and that's where this comes in. We only care about between 2 and 4. So go to your window setting, make x min 2 and x max 4, and then regraph it. And then it's just going to graph the parts that you need to see, so you can see what you need. Now you can see the intersection for that question. When you're done with that question though, you should do zoom 6 to put it back in standard time.
You said 3, 2,
Say it again.
I heard 8.
So sine of sine squared.
I don't know. Yeah, if you put it after the x, it looks like it's square and the x.
Okay.
You need to put it after that and right here. No. I was gonna see you say 5 times fast, but I thought that was.
On, But like if I'm distributing it,
As soon as you get it, it's great.
I got it done in some type. I wrote it backwards.
Oh, okay.
But yes, it was.
do I have to distribute negative to two?
And I think mine is all word of operations, you're gonna do multiplication.
So, distributable?
I would multiply these together first and then distribute them.
It's always simple.
If it looks like one of the answers,
So you can just memorize those.
that's not the same. How do you close? But that could also give you a hint on how to simplify it.
Green card gets like all those layers. I got that.
Okay, you also have about 15 minutes. If you're gonna have any calculator questions though, you need to ask as soon as possible.
I'm getting the hint that it's this one, but I don't know how they would like.
Okay, I'm gonna go backwards.
Well, you can factor out an x squared out of the numerator, and then that x squared gets canceled with this x to the 6 and reduce it.
I understand that, but I don't know how they have like a negative 3 out in front. But that one there's negative 14x.
Well, I don't know that that's the answer.
It's the only one
It could end up being that one. I would factor out the numerator and then reduce the x's to the x's. And then see which one it actually is.
Obviously, we're trying to do like. Oh, the residents?
Yeah.
I didn't say there. I think I did in quiz 2 weeks ago. There's like a starting chapter 1 was the first week of the month. So it's like just like stuff I think it's like chapter. I took mine a few days ago. But like, yeah, no, literally, it's like your notes are worth more than the actual quiz. Your notes are so the quiz is so the quiz is the assessment. The quiz is the assessment. It's like 10 questions, 10 questions. Yeah, we can do it for her. We were just like, we drove this out.
No, I don't. Skip it for just a second and I'll look at my paper.
You get an 8.2.
I tried to do it where k is equal to this silver. Like I tried to plug it in. So like I thought you tried to do it. So that's plus k. Yeah, no, I got that.
Oh, you're. I think the way you're doing some of this, you're just missing a sign or something, the way you're carrying this over, the way you're doing those out of order.
Okay.
So you got a negative. Why is that guy negative? There is a sign, it's cosine. But also, the writing them in backwards order makes me really nervous. Well, for Katie, you put in your calculator, what you have all these can all be numbers. X equals all this, Y equals that, so that. As in you graph, graph all this over that, before getting to the one that one thing off. So bad. Where X is
Yeah, I just.
Some of them are, some of them are, so she said,
Doing both? No. Okay, then you need to get back to it, please. You still got 10 minutes.
like, figuring out, like, a good way to write this, like, like, after, like, because it looks like a crazy number, it's not as bad as my last.
Two people want to do more to it. So when you multiply these together, why don't you write down what you think comes out to the total? Let me grab my paper because I think I did this. No, actually, you went about it a different way than me. So I don't know if I worked any better. But I split apart the fraction first, and it still wasn't as pleasant, but. It looks like your denominator was okay, so you might have been close. I don't know. Me personally, I tried to short product before it goes much. If I can rewrite the entire rule, I'm going to do that. Which what? With what? Both? You've done both. The certainly can link me to send it to Google Classroom before the next class. So you can do that. That was the Power Rule one.
Okay, I'll take a photo of it.
And If you get all that done, then I guess you don't have homework. You gotta be more.
What's the next step after this? Yeah. I don't know if I should like this thing nervous the way you wrote this one. This is times all of this, not just times the first one. The way you wrote it, it's like times 3x. Okay, otherwise I'm fine with your derivative, but then it's a matter of some time. So this is a complex fraction, we've got a smaller denominator and a bigger denominator. So to simplify this, you really want to multiply this by 2 squared of x, cancel that out. And then you gotta multiply this by 2 squared of x and this by 2 squared of x. And then that's what we close it, but I don't know if that's enough. When you divide things with the same base, you subtract the x. This isn't negative. It's only negative if you move it up. And here it's positive. So 1 minus a half is a half. 1 over cosine is secant. So 1 over cosine squared is secant. So wait, don't you remember I asked you to memorize this one? The derivative of tangent is. You got memorized. But once you memorize it, you can skip all of it.
So is that
I don't know what you came from. Alright guys, y'all have about 3 minutes, so make sure that you see where you need to be by next Tuesday. If you did not finish both of these circuits, you need to do that. And there's one assignment to turn in. That assignment is the power rule circuit we did yesterday. That needs to be turned in before I see you on Tuesday.